Cryptographic algorithms are often going to be grouped into two broad categories, which we see, and these are symmetric and asymmetric. Today's popular crypto systems use a combination of both of these algorithms to make it even better and more effective. Symmetric and asymmetric algorithms are distinguished by the types of keys that are used for both encryption and decryption operations, and we'll see how each of these are different. First of all, we have symmetric encryption. And this is a method where the same algorithm and secret are used both to encipher and decipher the message. It's also known as private key encryption because you need to keep the key private. These can be programmed into fast computing algorithms and executed quickly because they're relatively simple. Now, one of the problems with this is that both the sender and the receiver have to possess the same secret key. So they use the key to encrypt the message, and then that same key is also used to decrypt the message. Now, if either copy, the one that the sender or the receiver has, is compromised or gotten by somebody else, then whoever stole that can decrypt and read the messages without ever the sender or the receiver knowing. There's some different standards here. There's DES, and this is one of the most popular symmetric encryption crypto systems. You see there's a 56-bit key. There's triple DES, which was created to provide much more security beyond that. There's AES, which is even newer. So there's a number of these standards that are out there. I'm not concerned about the specific differences between them. Just realize that there are multiple symmetric encryption methods that are out there and able to be used today. Now here's an example. So on the left we have Rachel at ABC Corporation, and she creates a secret key. She must somehow get it to Alex at a different company out of band, which means not via the same circuit or same transmission path that they're going to send messages on. So if they're going to send, let's say, emails back and forth across the internet to each other, then they don't want to send the private key across the internet as well, because someone could potentially steal it across the internet and then use it to decrypt the message that are going across the internet too. So out of band would mean that she could send it to him via maybe a thumb drive in the mail, or she could call him on the phone and tell him what it is, but use some other method in order to get it to him. Now, once Alex has received it, Rachel can then use it to encrypt messages, and then Alex uses that same key that he has to decrypt the message. Asymmetric encryption is going to be a little bit different. This has two keys, so it incorporates more complex mathematical operations to encipher and decipher a message. Either key, either the public key or the private key, can be used to encrypt a message, but then the other key is required to decrypt it. So this is known as public key encryption. In general, what happens with asymmetric encryption is that you have a public key which you can give to anybody and everybody. It can be posted on the internet. It doesn't matter. And that key is what is used to encrypt data to send it to you. Then you have a private key, which nobody else has access to. You keep it only on your computer, and it's used to decrypt the message. So the only way to decrypt the message that was encrypted with the public key is to use a private key to decrypt it. So it's a much more secure method in that regard, because you're going to have the only copy of the key that can be used to decrypt the message. So in this example here, Alex at XYZ Corp wants to send a message to Rachel at ABC Corporation. Rachel stores her public key where it can be accessed by anyone, so on the internet somewhere. Alex is going to retrieve her public key and use it to create ciphertext or to encode the message and sends it. And then she decrypts it using her private key. Now, the encryption key size is going to be a big determinant of how effective the encryption method is. The strength of any of these encryption algorithms or crypto systems or anything is going to be measured by the size of the key. The security of the encrypted data isn't dependent on keeping the encryption algorithm secret because those things are publicized. Again, it all falls down to the key that's used in order to decrypt the message. So the larger the key, the better off it's going to be. In these next few slides, we look at some examples of how long it takes to crack. So in this example, it bases this on a 2015 computer with a certain amount of processing speed and other characteristics. So in the leftmost column, you see the length of the key in bits. And on the right, the estimated average time to crack that. So if we have a key that's 16 bits in length, it takes a fraction of a second. Same thing with 24 and 32-bit keys. Now when we jumped up to 56 bits, now it takes 2 days. 64 bits is 21 years. So you can see that by just adding a few bits, it significantly increases the amount of time to crack, all the way to the point where we get to 512 bits in length. And now we've got a number so huge we don't know what that is, but it's in years. So, the length of the key is going to be the determining factor in how secure that encryption algorithm actually is. Now there are different kind of tools that are used for cryptographic encryption. Potential areas of use for all these include, as we mentioned, concealing the contents of sensitive messages, so being able to transmit emails back and forth and not have those messages understood by somebody else. We can also use this a little differently. That would include verifying the contents of the messages and also identities of their senders. So there's, again, other uses for these cryptographic tools that are out there. Steganography is another method of encryption that can be helpful today. And this is the process of hiding a message inside of a picture or a graphic. And this has been around for a long time. Most modern versions are going to hide text messages within files that contain digital pictures or images. So we can send a text file and include it in a bitmap image, a WAV file, an MP3, or any other form like that. And so the image that's going to be transmitted could go across from sender to receiver and look inconspicuous because it looks like just a graphic. But then we can use some software to also extract that text message or that text file out of that image. So it's just a good way to hide messages going back and forth between somebody. Now, there are a lot of different protocols that use secure communications, and we see them on the internet and so forth. So we see a lot of different methods, a lot of different uses for cryptographic protocols, even into wireless. Now, we're not going to get into this in depth right now, but you've probably seen WEP, WPA, WPA2 as encryption methods for wireless communication. There are others that are getting better. Bluetooth also is another wireless protocol, and it's relatively unsecure unless you take the time to secure it. Anyone within about a 30-foot range can access a Bluetooth device unless you have the encryption or coding turned on. As we look at WEP versus WPA, these wireless protocols have been around for a long time. You see, WEP is really not one that's used much anymore. WPA is still used quite a bit, and you see one of the reasons or one of the differences in these two methods is really the size of the key. WEP uses 40-bit, WPA uses 128. There's some other differences between the two as well, but that's one of the biggest reasons behind WPA being much more effective than WEP. And there's other wireless protocols as well, and we'll talk about those in a different chapter.